Today's video, we're going to make a USB dock for a portable gaming handheld PC. Let's get to it. Hey there YouTube, this is SGM4306 and stop. It's cable time. I've been wanting to say that since I found out the company's name. Anywho, Cabletime has very kindly sent me two of their products. This is sort of a review, but it's also sort of a project video because I described to them an idea that I had for a project using their adapters / cables, and they were ecstatic on it. So they very kindly sent me the parts necessary. So what I'm going to do in this video is I have an Ayn Loki Max, I think it's called. It's a handheld gaming PC, and unlike every other portable gaming PC, the USB connector's on the bottom, so it's really awkward to plug into. I have a dock that's made for a Steamdeck, and its USB-C connector's on the top, so obviously it's made to sit upright, so it's super awkward. I have to put my console in upside down to get it to plug into the dock, you know, and like kind of prop up properly, and it's like not great, and it blocks the exhaust vent. So I really don't like that. So I wanted to, I looked online, and they do sell handheld gaming PC docks for like different consoles that have the port on the bottom, but those are like super expensive. They're like $80-100, and like they go out of stock and in out of stock because there's not many companies that apparently make that style of like all-in-one USB-C dock anymore. So I'm gonna make my own for much cheaper. So here we have the necessary components, other than the power brick, obviously. But we have a USB-C to C cable, and this guy is way higher rated than I would ever need. I think my console will only pull like 60 watts, and like it might. The brick it came with is a 100-watt brick, but I don't think it's not going to pull anywhere near that power. But this is way overrated, 240 watts, which is ridiculous. So this should be able to like full charge like gaming laptops and whatnot. So this is pretty beefy. I can already feel kind of by the weight. This is only USB 2.0 though, 480 megabits per second. I believe they do sell slightly more expensive USB 3 versions of this cable, but it also is made from zinc alloy, and it's one of these magnetic cables, which is awesome. I've always wanted to try one of these out. So it sort of self-coils because there are magnets actually inside the cable. So I guess without further ado, yeah, okay. Let's just pop this guy open. Yeah, and that's it. It says nickel plated, the actual connector, and the shell is zinc alloy silver. I kind of don't really know what they mean by shell. Oh, I guess the actual tip, this gray part is zinc alloy silver. That's interesting. Okay, I got you. So yeah, it says at 48 volts, 5 amps, and that's what gives you the 240 watts. So that's insane. And it uses sort of that flexible, like fridge magnet material, I believe, on the actual cord because it has to be flexible. And yeah, and they have like their own QR codes, so you know it's like legitimate and whatnot. So here is the cable itself, and it does come with a warranty card. Let's just see how long the warranty is. Okay, it says you can return without any reason within 7 days. Fair enough. What's the actual? Oh, there you go. Okay, so the service warranty is 24 months. So 2 years they'll give a warranty on the cable if it breaks or anything due to like poor manufacturing. Though I gotta say, just feeling this feels really high quality. They do have like a protective film. If I can figure out how to how to undo this. Okay. Yeah, this magnetic film this plastic film is kind of a pain in the butt to peel off. But anyway, once you get it off, yeah, it like feels nice and dense metal. Like really nice thick overmolding too on the inside. And yeah, it is like a slightly stiffer USB cord, and it definitely does like want to retract because it is magnetic, and there's, I'm guessing, like the material itself is sort of has like a memory. So it's not gonna super lie flat, but sort of you let it go and it just sort of like automatically curls. That is pretty cool. And yeah, it's exactly, it feels like that fridge magnet material where it's like not super strongly magnetic, but definitely is magnetic. That's pretty cool. The length is, do they say here? 1 meter, which is, yeah, it's about 3-ish feet, like 3 point something feet. And yeah, this is a decently beefy cable. And on the other end, I got their right angle connector, so that I'm going to design and 3D print a dock. Maybe I'll even go as far as make like different inserts so that you can like dock a phone into it, or the game console, or any other game console that I might happen to get in the future for charging and data. That might be cool. But I got this little right angle connector job here, and that's interesting artistic sort of symbols there. And they don't really give you specifications for this, I'm guessing, because it's just an adapter effectively. It's extending the pins, so hopefully this does USB 3 through it. As long as all the pins are just straight up connected, it should just work with no matter whatever cord you plug in here should be the limiting factor. Got this nice and tiny one, so I can just design it to like slip into 3D print. And yeah, this looks like it'll do the job. Nice positive click. And obviously it's USB-C, so it'll go in either direction. Oh, here we go. There is some specification doodads. This is also capable of doing 240 watts. So with this cable and this adapter, if I can get it to focus, yeah, this can do like a ridiculous amount of current. That's awesome. It says 40G 8K, so I'm guessing that's like the speed rating they're trying to say. So that sort of hints to me that hopefully this will be fine for like any high-speed USB 3.0 connections that I need to make. We'll test this out on the gaming console in a sec to make sure that it'll actually work for how I intend to use it. But one thing I am noticing, I thought it was going to be like a flat box. There are some curves to it, which when I model the insert to the 3D print, I'm going to probably have to measure these curves if I want it to fit like very nicely and snugly, which is how I'm going to want to design it anyway. The ends are flat though, so that's easy enough to model. And they're like little ridges, like heat sinking. That's interesting. I guess it sort of makes sense given what volt or what power this is rated for. Feels like has some weight to it. You know, despite it being this tiny little piece of, you know, adapter, it has a little bit of weight that's undoubtedly the metal casing for it. But yeah, so I guess all we got to do now is take a bunch of measurements of this and design a dock around this. And also take measurements of my game console so it'll actually fit it. So let's get to that. So here I have my dock, and I think this is, yeah, Kiwi Home branded dock. I have my console just booting up. I'm going to test this adapter. You can see what the problem, though, is this is a right angle connector, but it goes in the opposite direction. It goes vertically, and the cable's like super short, so I hate this. Like the console itself will just about fit inside this slot, but then it covers the entire USB port. So there's no way I can insert. If this were sideways, I could maybe just like prop this up and like hot glue it in there or something, or make a little 3D print that can hold. But it can't, because it has to be through the metal. Like this is just a fixed thing. This is supposed to go into a Steamdeck where it plugs into the top like this, and the Steamdeck just sits in here. But clearly my console's not a Steamdeck. So I'm just sort of realizing a problem I'm gonna have. I should have asked for one more piece to this puzzle, which would have been a female to female type C coupler, because this still isn't gonna fit inside. I'm gonna have to make like a separate dock thing that sits to the side. I'd planned on plugging this into the L connector, and so I can create some distance between this dock and that. But yeah, clearly, just for testing, we're going to see if this L bracket adapter thing works here. I'm just going to plug in a thumb drive And if the data pins are all working and whatnot, then it should be able to access the thumb drive from there. There we go. So I have that ready. It is plugged in. I am seeing data accessing, and it does pop up. So yeah, I think this is going to work now then. And it's saying display connection might be limited. I think that's because I don't have anything plugged in here. This does have HDMI and what is that, DisplayPort, I think. So I could output video on this. So my idea is to make this like a portable dock thing that I can turn this gaming PC into like a full-on PC, but with all the ports that I need access to. This even has Ethernet. So I could go traveling with this and use this as like a laptop replacement. That would be really cool. So obviously this little adapter is going to work, but I kind of can't plug this in between the L bracket and the original cord. And really stupidly, I'm just going to plug this. The original cord is hard soldered. If they had just put a Type-C port on there, I could have used any cord like this and just plugged straight in, but I can't because of the way that this dock is designed, and I don't want to buy another dock. I could solve this problem by spending more money, but I'm trying to avoid doing that. And clearly I could plug this in straight to the bottom, but yeah, that's less than ideal. I kind of wanted to just 3D print an insert that just go in like this, and then you'd be good to go. And there is a Type-C port on here, but there's only one, and that is what's necessary for the power input. So yeah, this is unfortunate, just the situation that I'm in with the parts that I have on hand. I think I'm gonna need to get an adapter, like a C to C female coupler, so I can plug this into a cord, so I can get a straight connector into here from the side. Because right now I hate this style of right angle is like not useful for me. It would have been better if it were flat like this. They could have just replaced it. I was actually tempted to just cut this off and solder my own plug or whatever onto it. That's kind of a lot of work, and if I mess up the wiring, could damage something. Anywho, I'll figure something out. But for now, let's design sort of a little dock thing that this can slide into and then allow you to plug in, any kind of cable that you want. Okay, here we are. Here's the completed dock. I'll show you some renders and maybe go into a little bit of detail about each of the individual pieces in a sec. These are all, well, with the exception of this riser, these pieces are pretty much permanently attached. I set the tolerances like really tight. I think I only had 0.1 millimeter. And when I did a fit test of a short piece, it slid fine. But obviously when the keyway shape goes the entire length, there's just too much friction. So I probably could pull these apart, but I would need to do so with like a vise and a hammer and probably risk damaging parts. So I'm just not gonna. These fit together like one time and then they are stuck in that position. Anyway, as you can see, I basically modeled the right angle connector and then created like a keyway cutting tool that I did like a negative of within the base, so you could see it extends all the way here. And the USB cable on this is fully removable, and you can remove the dock, use the dock externally, and this piece is just wedged in there. So that's actually friction fit. It's pretty tight of a tolerance as well. I did everything to 0.1 millimeter tolerance, so that seems to be like a good tight fitting value where it's not going to slide out on its own. If I grab this and I wrenched on it, I could get it to start sliding out. But the friction between this back piece and the base is just kind of a bit too much to really fit. You will notice that the dock itself has these curves, which I did not bother modeling in the cutout for it because I just got all the other tolerances, and that's good enough. It doesn't matter if it fits exactly. There's enough pressure that it's not going to come out on its own, but you can put your finger in there and push it out and it'll come out perfectly. It just sort of clicks in. I did put a little hole for the Ethernet cable. There might be an issue. I forgot to put like a little cutout for the actual tab to release and insert it, so maybe I don't know. I'd have to grab an Ethernet cord, but you might need to like use like a shim or something to release the Ethernet cable if you insert it, if the tab isn't long enough, because this is recessed quite a bit. Probably should have added like a chamfer and like a little keyway cutout on that. I don't really ever plan on using Ethernet, so that's not a problem for me. The back, all the ports are accessible, including the USB-C power input, the two USB 3.0s, the two card readers, a micro and full-size SD, as well as HDMI. And so all you got to do when you want to plug this dock in, you just sort of got to insert this cable, and the cable's like stiff enough that you can push the cable to actually insert the end into there. I know it's not ideal, but this actually works pretty well, I think, for how I'm going to use it. The very unfortunate thing is this cable length, I could have made the dock wider to cover the cable in like an internal channel, but it sticks out in the current rendition. I don't really care. It's sort of a like a little handle for it, so I don't mind that too much. I understand it's not aesthetic and it's kind of If you look from this side though, yeah, it is like pretty compact. It is smaller than the console itself. The angle that I set when I designed this, I just sort of set it by eye. I think it was somewhere around like 5-6 degrees, and it looked okay in the CAD model, but when I actually printed it out, it is sort of a little bit too vertical. I mean, there is like a back curve to it. It does lean back a little bit so that I'm not worried about it falling forwards, but not so great. So I ended up, instead of reprinting all these parts, like these two parts together, I think is like 80 grams of filament, which is like 80 or 100, I think it ended up being, which is like kind of a lot of filament. I don't want to be throwing out filament for no reason. And so I ended up printing out a small base that adds like another, I think like, what was this, like 15-20 degree incline. And it doesn't glue on, it doesn't snap on, it just sort of sits, and there's these two little cutouts in the back that sort of centrally align it so that when you put it in, it just sort of sits there. And that actually adds like a decent, to my eye, incline to it. So when it's sitting on a desk, it's like the perfect angle and height. And so that's good enough for me. In the future, if I ever have to or want to redesign this, I'll definitely design the incline into the base piece. So these two will be one piece that you just print out. All the parts are oriented to print vertically. You'll see the edge here isn't quite so perfect. I added a brim because the surface area contact for this top piece was kind of small, and I was worried about it breaking off halfway through the print and ruining the print. No other supports are necessary. On any of my parts, no supports. Everything just printed out as is. I've set all these for ventilation holes so that it doesn't cover the back, because the back of the console has like a bunch, like a big fan array thing here, and I didn't want to block the holes and overheat the console, so I put a bunch of holes in there, and they all printed just fine. Maybe there's like a little eccentricity to them at the top there because it printed in this orientation, but I'm okay with that. I kind of went a little bit crazy with the thickness on this back panel. I probably could have made it much thinner, honestly. But it's plenty strong. Like, this is never going to break off on its own. Like, you would have to put serious force into it. And this bottom piece as well was printed vertically. And I did not need to use support for here because the bridging gap is pretty small. It's only like not even 5 millimeters, I think. So plenty of space for it to just bridge, so that wasn't an issue. I use constantly the, there's like a intersect command or something, and I use that constantly for when I design one part, I design the other part and just like added them together in the same sketch and then overlaid them so that the features of this keyway, for example, would automatically be cut out of this piece once I use like the intersect command. And I was able to also add a clearance on top of that. So I think next time if I'm going to print this again, I'm going to increase that clearance a little bit. Maybe go to like 0.15 or 0.2 because the 0.1 was pretty difficult to insert. I ended up having to take a rubber mallet and set this on like a rubber surface and then lightly tap this while I was inserting this. You can see this is captive. Like, I can't slide this out without sliding the gray piece completely off the white piece. So they have to kind of be tapped into place together at the same time. And if I do design this again or make changes, I would definitely add a small hole here so that you could get an Allen key in and insert it to tap out this port, because right now the only way to get this port out is to grab it by the actual connector and apply pressure downwards, which is very uncomfortable feeling and could possibly damage that connector. But if I added a hole here, you could just insert a very long Allen key and lightly use a hammer to tap it out on the actual metal frame of the body of the connector itself. And so yeah, that's basically that. Let's just do a quick demo of this. I'm going to insert a USB dongle for a wireless keyboard so I can control it without using the touchscreen. I'm going to use the 240 watt cable that Cabletime very kindly sent to me. And that's just going to go in for power. And another thing is I probably should have made this cutout height a little bit taller so that this just barely fits. If this cable were any thicker, it would foul on the plastic. So I got lucky, but it's one of those situations I probably should have measured twice before I implemented it. So, yeah, we got everything plugged in. Or actually, no. I need power for my LCD. I'm going to use an external LCD monitor, and we have HDMI. So now we're all plugged in. One other thing, actually, before I go into that, it's very important when you're designing something and going to make something that has to fit real-world things, is to check tolerances on your prints before you dedicate like half a spool of filament to the print part. So I actually sliced off a little bit of the end. When I import it into the slicer, if you put a part below the bed, usually the slicer will just treat it as if it doesn't exist. So I basically lowered it vertically like this, down almost all the way into the bed until just the end was showing. And that allowed me to print out these two test pieces, which is basically the cross-sectional area of the base. And then this part is basically just part of this backstand part. And so I could check the fitment of, the key slots. And here, if it works, it's actually kind of slightly loose. And I think why is there's not that much surface area of contact. It's only like a small square. That adds up when you have that key go the entire length of the print. So I thought it was going to be kind of a loose fit that I could remove, and I wanted it so that I could actually make other top pieces that you could slide on for other devices. Because this piece, I modeled actually the body of the Loki, including the placement of the USB port and everything to get alignment perfect. So this actually fits literally like a glove. Well, not literally. It fits like a glove, and it just sort of sits down, and that's like perfect. There's like no gap, almost no gap between the back and the body, and the bottom curves match like perfectly. You could see there's like maybe a fingerprint or fingernail gap in between everything. But yeah, so I did that. The actual alignment of the back dock part took me 4 tries, I think. Yeah, 4 tries, and the 4th one I reprinted the full one because it worked correctly. You can see here the first try. Actually, let me see. I think I might have mixed up the order on these. Whatever this try was, you could see the USB port was 2 backwards. I had to move it forwards. And I did the same trick that I did for testing tolerances with these plates. Was I moved this top part of the dock kind of below the bed, right underneath the USB-C connector, and then I added a primitive that cut off the top of the part so I could just print off a small section. These are only like 5 grams, and they ensured that I got the alignment all correct before I dedicated like a full 30 grams of filament, or I don't know how much this was. This was actually quite a bit. I think this was probably like 40 grams of filament, the gray piece. So it saved me from printing out that 4 times incorrectly. This piece, I think I got the alignment correct. But I forget, there's some other issue. I think one of the issues was, the thickness of this bottom piece. The connector is actually sunken into the part. So if this bottom piece, the bottom of the console, and then the actual like top of the body of the connector is too far apart. The connector will start sliding in, but the data pins won't actually click in and connect. I think that's what the problem on this was. This one, the fit was all right. I think I made this, I made this a little bit thinner. You could see this is thicker than like this area. Yeah, there you go. And so that was one of the modifications. This might be the first one. No. Oh yeah, I think this one was the last one. So I had to make it thinner twice. The second time I didn't go quite aggressive enough and it still wasn't connecting as well as I would have liked. And this one ended up being the correct one. You can see just how thin that is. You can see it gets thinner as you go to the right. And yeah, so that's why I had to do 4 iterations of that to get it just right. And we can just plug this into the wall, I guess. I will punch out. So there's nothing plugged in right now. It should be getting power though. And I should be able to just dock this. And it is charging. The yellow light came on. And if I hit this, it will turn on. And then hopefully the monitor is going to kick in eventually. I think once it boots up into Windows, it will actually duplicate the monitor. Let me get logged in and everything, and then I'll show you guys once Windows is booted. So that's weird. The other monitor didn't work, but I plugged in a second USB-C monitor and it works. So I have no idea what's going on. Some kind of incompatibility. Maybe the cable on the other monitor something's wrong with. Anywho, it just kept saying no signal, but this worked right away as soon as I plugged in this monitor. So clearly you could see I'm using my trackpad. I guess I'll just punch in on the actual 2 displays and yeah, you can see I'm moving the mouse. I can, this is all connected over USB, wireless USB, like 2.4 gigahertz, using that dongle in the back. But yeah, you could see now I basically, if I had like a full-size monitor and keyboard setup and everything, this would turn my portable gaming console into a full desktop computer effectively, given integrated graphics and whatnot, and limitations of this size of computer. But yeah, you can see here, I mean, it's Windows. What do you expect? It runs just fine. I only have a 1 terabyte internal drive here, and then I have a 1.5 terabyte micro SD card. So that's as much storage as I have. I could probably go 2 and 2 to get 4 terabytes total, but the 2242 cards are quite expensive, and the 2 terabyte micro SDs are pretty expensive too. So I'm gonna hold off on that, but yeah, you can see I can go into my library, and let's fire up. Apparently I have to do an update. Great. So I guess while this is going, I'm just going to waffle on a little longer. So all in parts, if I had to buy, you know, the USB dock, the cable, the right angle adapter, the filament, well, I did buy the filament, but all in, this was less than $50. I'm almost absolutely sure, or like maybe a little bit above with tax and shipping or whatever. But the cheapest docks that I've seen that do the USB on the bottom of the dock, they're like over $100. Almost all of these types of portable gaming docks, game handheld console docks, always have the connector on the top because of the Steamdeck. Because Valve decided to put the connector on the top, so all the docks that are like cheaply available and are on the top, unfortunately. So like none of them would really work while standing up my console. I would have to lay it down on the table and block airflow and whatnot, and I wasn't happy about that. Can you wake up, please? Yeah, I'm definitely gonna have to change that screen time. That is way too short. And yeah, but yeah, so like for about 50-ish bucks, 50, 60 bucks, this isn't a bad solution, I think. And I can always take the dock out and reuse it somewhere else portably. And if I had gotten the tolerances right and designed with a little more foresight, I could have made it so I could reuse this right angle connector with like other shells and stuff, but it's kind of wedged in there pretty tightly now and probably difficult to remove, so I'm not going to mess with it. I'm just going to leave it in here from now on. But yeah, overall aesthetically, I think it looks pretty sharp. It has like the tricolor kind of orange, white, and gray, sort of like Half-Life aesthetic sort of thing going on. which I think looks kind of cool. It doesn't look out of place on my desk. It holds the console at a pretty nice angle. I got like the angle of the USB connector and everything like perfect, and definitely like using the import body command in SolidWorks along with the intersect command helped a lot to get everything lined up perfectly. And yeah, I wasted a little bit of filament making some test prints, but it would have been far more if I had printed out the full thing, assembled it, only to find out that it wouldn't fit properly. So pretty happy with that. Yeah. And this same design methodology could be used with any dock. You would have to change the files, obviously, and redesign it and like change the cutout and the design of the angles and stuff to fit other devices and other docks and other right angle adapters. But that's not really that difficult once you kind of understand how 3D modeling works. It's actually pretty easy. So I'm really excited actually, because this means I could make like any custom dock solution that I could possibly want for any device that I own, as long as I can model it. And then yeah, that's it. Looks like we are finally done, so I'm just gonna clear, go back, and we're gonna play this. Now I don't have a game controller plugged in, I just have this USB keyboard, so it's going to be questionable whether I can control this or not, but man, this is just for testing purposes. I mean, clearly everything does work as plugged in. The HDMI output, it is charging. If I go into here and open the Loki Control Center, you can see it's already at 100% actually. Might help if you could see that. Yeah, at 100%, and I only have it set to 8 watts for some reason, but whatever. Should be able to fire this up in a sec. Get the big screen. So this is kind of something I always wanted, like a portable game console that you could just use like a portable, you know, like a portable desktop sort of thing. This would be awesome for like LAN parties. Given this is not going to volume's kind of loud. Just decrease that. This obviously is not going to compete against like a full desktop, but also this could fit in my backpack, whereas a full desktop would not, clearly. And some of the portable game consoles that are coming out are like ridiculously overpowered now, so this is definitely viable, I think, as like a portable LAN party gaming kind of setup. Just build one of these docks for your specific handheld. And yeah, it's not really expensive at all. Just gonna load game, load. Sure. And just have the volume down for copyright reasons. WSAD? Okay, yeah, WSAD. Wow, this is super awkward playing on a tiny handheld keyboard. But yeah, we're doing it. Wow, the touchpad is the the camera angle, and it is super awkward. Okay, I have no idea where I am, but gotta try to make my way out of here. Yep, I think I'm, let's see. Okay, it up to 12 watts, and I think that might be too limiting of the TDP, because it is not really doing so great. It's stuttering and lagging every once in a while. But, I mean, like, this would be playable, like, in a pinch. So, all in, this was a fairly simple project to do. How do I menus tab? Let's just pause the game. Yeah, this was actually a pretty simple project to do, honestly. And the results are actually, like, they're better than I expected, honestly. Yeah, would I recommend people doing this? If you have a 3D printer, the cost of entry is even cheaper actually. But you could still, like, I'll upload all these files if you guys want to download them. If you happen to have the exact console, buy the same cables, and you're okay with everything design-wise, then by all means I'll provide all the files for free, and you can either print them yourselves or get them printed via like a service, online service. But yeah, if you have a printer, like, just kind of, I'm gonna make more of these. I'm gonna buy a bunch of these right angle connectors from Cabletime. And yeah, that I guess brings me to, once again, thank you so much, Cabletime, for sending these two adapters, well, cable and adapter, in. This was a bit different than just like the standard reviews, because I actually wanted to make something with your product, and I've been thinking about this for quite a long time. I almost caved and bought like one of these docks pre-made, and it was like over $100, and I was thinking, like, I could just make that. There's no reason I couldn't. And then as soon as Cabletime reached out to me and I looked through their site, I was like, hey, they have cables and they have time. I mean, right angle adapters. Like, there's no reason why I couldn't do this. And designing this took like 2 afternoons, basically. Printing it took like maybe 3-4 hours apart. The base was pretty quick. It's much smaller. But like the top 2 pieces took like maybe like 3 or 4 hours each. So it wasn't too bad. So yeah, absolutely. If you want to see like more maker projects like this, just let me know, because I'm always up to make stuff. A lot of times it might take a little while for me to get around to different projects. But yeah, I want to learn more CAD. I want to get better at CAD. And when you're done, you can just, lift this off and, powers off your monitor, and that's it. And now I'm just portably in here. How do I go home? So yeah, it took me a second to remember how to exit out of the game. But yeah, this is a dock. As soon as you plug it in, it'll automatically go, and for some reason it wants to open up Steam. But yeah, here's my desktop. Yeah, this was an absolutely awesome project, and I'm really happy, and Cabletime was like really understanding about sending me the parts I needed to complete this project. I just gave them a vague description of what I wanted to do, but they were all for it, and they kind of gave me like a massive amount of leeway for completing my dream dock. So anywho, hopefully you guys enjoyed this video, and I will see you in the next one. Bye. Quick addendum, I just wanted to say, you don't need like a massive amount of tools or anything to model something that exists in the real world physically into a 3D model. You can see here I drew like profiles of like all the parts I needed to model and get into 3D space. And all I really needed, pair of calipers. These aren't even like a great pair. These are okay, not super high accuracy or anything. And a radius gauge. You can buy these. I 3D printed this one, which goes from 1 to 14, as well as I have I have a set that goes from 1 to, let's see, 20, and it does both inner and outer radius. So these are obviously for the outer radius, and then there's an entire set on the other side for inner radius. And that's all I needed, honestly, to get all of these measurements. And then I can use that while I'm designing the part in 3D space in my CAD package. And that was sufficient to allow me to design around that. And so, yeah, obviously, if you don't have the 3D printer to 3D print your own radius gauges, you could just buy them. They're not super expensive. They're literally just like pieces of plastic like this that are just molded to be the right whatever their measurement is. Anywho, yeah, these are the USB-C dock. I measured everything as accurately as I could. Not like super accurate too. Like you could be off by a little bit and it's still probably fine. And this is the right angle adapter. I modeled everything, and including all the curves and stuff, so I can get it like decently accurate enough that I could design a part around it that will like either have a loose or a sliding or a friction fit. And that was good enough. This is the dimensions of the keyway. I just wrote it down just in case I wanted to know in the future what worked. And yeah, the features are pretty small on this, like only like 1mm feature size for like the different thicknesses. And apparently my printer is fully capable of resolving these units and printing out both sides of the keyway and having them fit like pretty tightly. So yeah, very happy with that. Anywho, back to your regularly scheduled programming.